All right, good evening here, everybody. This is Matthew Gross for Lebanon County Weather, talking about Hurricane Irma and a potentially catastrophic situation that's going to be unfolding in Florida here over the next 72 into 96 hours as you spread up even into Georgia. And we're going to talk about the track, but I also want to get into something a little more specific about the damage potential and why I think this could be absolutely historic beyond anything we've ever seen anywhere in hurricane history, perhaps doubling and tripling the previous record for most costliest hurricane in history. Let's quickly go to the visible shot. You can see another one here is the sunsets of Hurricane Irma, of what it looks like right now. An absolutely devastating high-end Category 5 hurricane, 175-mile-an-hour winds, pressures at 922 millibars. That's as strong as Hurricane Andrew was when he made landfall, and it's possible this could get even stronger before it makes landfall. Let's quickly look at the National Hurricane Center's current projected path, and it takes the absolute worst-case scenario path, which we're going to be talking about in this video, where the system essentially comes right up the spine of Florida. So you can see here it comes along to the west as a major hurricane, probably either a high-end Cat 4 or very, very close to a 5. It comes very, very close to Cuba and then goes up through the Florida Straits into South Florida. Miami is in the right front eye wall, and then it just follows basically right between I-75 and I-95, probably a little bit closer to I-95, but if it takes a path anything close to the center of this line, which the National Hurricane is showing, there is going to be a day that we have never, ever seen in Florida on Sunday. So let's quickly go into, it shows a little bit easier in the models as well, and backtrack here. This is the American model, the GFS model. This is the model that had been showing a solution a little bit further to the east early on. It was showing it come up through Florida and come up through the Bahamas and then go just over in this area and then come up and hit the Carolinas. But it has now begun to trend more to the west, more like the European model, which is going to display this catastrophic solution. See, here it is, very, very close to the National Hurricane Center's path, gets underneath Florida, south of it like this, and then turns north. In this case, 899 millibars is depicted. That's 23 millibars stronger than the storm is right now. What remains to be seen if it will get this strong, but there's a chance it might, and I'm going to show you that in a second, why it might. And then it just rides right up the state of Florida. Let's see if we can switch here to the to 10 millibar winds, so it might be a little bit more accurate to what we're seeing here on the ground. And you can see here it is cutting up through Florida. Everybody seeing those purples and whites is either very, very close to hurricane force or hurricane force. And then down here where you see this semicircle of blacks and pinks and whatever's other color, that is major hurricane catastrophic winds that most of South Florida is going to experience. And again, this is just one solution. The eye could be here, it could be here a little bit to the west of this, it could be a little bit to the east of this, but if it takes this middle path, which the models are converging on that middle path, it is going to be something catastrophic that we just have not seen. So let's talk about some of the reasons why this path is going to be so unbelievably catastrophic that we just haven't, I don't know if every place has really gotten into it that much. First off is the water temperatures. So we're going to go for the three big reasons. Number one is probably the simplest, so let's get that one out of the way first, the water temperature. This map here shows the sea surface temperatures. The hurricane is going to be moving into this area over the next few hours. And what you notice here is the water temperatures in Celsius, 30 degrees Celsius translates to about 86 degrees Fahrenheit. So if you take a look at this brown color, where it goes from red to this brownish color, notice how these 86 plus degree water temperatures begin in about another 12 to 18 hours worth of path here for the hurricane as it comes through. And they only get warmer than that, showing some spots over here close to 32 degrees Celsius, which at this point you're starting to get close to about 89 degrees Fahrenheit with some of the water off of South Florida. And that is just pure jet fuel for a hurricane. And you can see, we already have seen what it looks like on the satellite picture going through this area over here where the water temperatures, 83, 84 degrees. Now the water temperature is only going to get warmer. So as long as you have low shear, which is going to be almost no shear to speak of to rip the storm apart, and minimal dry air or land interaction, there's not going to be anything from preventing this hurricane from potentially getting even stronger. The only thing that I see possible to weaken it is if it gets close enough to Cuba on our projected path here. We can go back to the National Hurricane's projected path. and that it might have a little bit of land interaction, or it might pull in a little bit of dry air off of some of the mountains of Cuba, maybe. But even if it does so, if it even maintains its energy to this point, it should then start intensifying when it makes this turn to the north away from Cuba and starts entering Miami, or starts approaching Miami. So that's number one, is that as strong as the storm is, it's not outrageous to think it could get even stronger, especially pressure-wise, or at least the diameter of the hurricane force winds could expand even further than they already are, which are already 75 miles wide. They're going to get even wider up on landfall. So that's number one. Number two is it has something to do with the geography of Florida and the direction the storm is coming in from and the depth of the sea surface. So we're going to switch here. This is a Google Earth view, and I think it shows it very, very, very well what we're looking at. So the surge potential in Miami. The storm surge is basically the number of feet above sea level that the water is going to rise. That is just from the winds pushing the water up onto the land. And there'll be waves on top of that. So if you hear a 5-foot storm surge, that's 5 feet of water higher than usual, but then there'll be waves crashing in on top of that. So it really, I mean, the storm surge number is actually sort of a conservative, can be a conservative estimate, but it gives you an idea of what we're looking at here. And the issue here for Miami is that when you have a hurricane coming up from the south, so if you follow, if it comes up in this general orientation, the problem is if Miami is on the right side, if to the east of the eye, so that would be the right side of the eye in this case, which is the worst side. If you picture the counterclockwise motion around the center of circulation, what's going to happen is if you are to the right of the eye, this fetch of water here is going to pile toward downtown Miami. And the reason why this direction is so bad is if you compare this to other hurricanes in the past, most of them have come in from the east and have come across like this. This is the normal direction that Miami's gotten hit historically. And if you notice, you have the Bahamas over here with these gigantic sandbars. And if you can see here in the bottom corner of your screen, this number right here is going to show the elevation that we're at. And if I put my mouse over here, you can see that you have less than 100 feet of water depth here. So, in other words, when a hurricane approaches Miami from this direction, what happens is the only real ocean swell surge that you can generate, you can see when I put my cursor over here, you have over 2,000 feet of water depth. The depth of the water is only being generated, the heavy surge is only being generated between here and here. If a hurricane's coming in from this direction and it's pushing water in. If this Irma comes in from the south like this, it has all of this, as you can see by this color here, this different color depicted different from here, it can push all of this water in here up into Miami, which is just the absolute most disastrous scenario possible, because now you have the potential for historically high surge because you've got it coming from a direction that you normally don't see. And if we zoom in on Miami, you can see that there is an outrageous amount of expensive property here to damage. So if you start taking a look here, remember the wind's going to be coming in from this direction, from either from south to north or from southeast to northwest, depending on exactly where the eye is in this situation. But again, if the eye goes to the west of Miami, it's going to be from either this direction or in from this direction from the south, and that's almost a direct orientation on, if it's from southeast to northwest, into this area. So you've got South Beach, which is over here. This is Miami Beach over here. This is where you have Ocean Drive and all sorts of expensive properties in here. The average sea level of this island here is 3 feet. Some parts get to 6 or 7 feet. So if you get a 10-foot surge, this entire island could have water on it. It could be completely submerged with waves on top of it. Down in over here, you have the causeway. That causeway could be, the MacArthur Causeway, that could be completely underwater. This is the port of Miami over here. This is where you have the cargo ships and the cruise ships come in. And then this area back over here is downtown Miami, where you have all sorts of expensive real estate. Again, much of it below 10 feet of sea level, that the water is just going to push in to all of these areas with waves crashing on top. And again, if this surge is over 10 feet, you're going to have catastrophic damage inside of this entire area over here. And then you've got even little places like here, you see Star Island. This is where, you know, many millions, movie stars, NBA players, you name it, live on here. So the level of property expense in this area is just through the roof. This is probably the most expensive city that you can have a hurricane possibly hit, except for New York. So the price tag for this that you're talking about is just going to be absolutely outrageous if it hits in this fashion. And then the other thing I want to talk about of why this is going to be so devastating is we look at elevation and population. So first of all, this is Florida's population right here. Right now, you can see most heavily populated down here in Dade and Broward County because you've got Miami, you've got Fort Lauderdale, you've got West Palm Beach, other counties up here, Tampa, Orlando, Jacksonville, all in red. And if it takes the path, if Irma takes the path the National Hurricane Center is currently projecting, and the path I currently very much agree with them, up through the state, you're talking about the eye passing within 100 miles maybe within 75 miles of pretty much all of these most populated areas. The only unpopulated spot in here is really the Everglades. That's it. Everything else is very, very, very well built up. And that really shows through if you just do a simple Google search of Florida's population, and it will show you what it has done over time. You see Florida's population right now is up over 20 million people. If you go back to, let's say, 1960, which was the last, or 1965, we'll do Betsy, was the last time, you know, the last run of major hurricanes. Between 1920 and 1965, there was a run of just, Florida was getting hit all the time with hurricanes. And if you go back to that point in 1965, the population was just crossing 6 million around that time in Florida. Since then, they've really only gotten hit with Andrew and then a bunch of storms in 04 and 05. But for the most part, Floridians have not seen the nasty side of the cycle, where you had a Tampa hurricane in 1921, a Great Miami hurricane in 1926, Lake Okeechobee in 1928, the Florida Keys hurricane in 1935, Fort Lauderdale in 1947. I could go on and on and on and on until Donna and Betsy in 1960 and 1965, Dora in 1964, Cleo 1964 also. But in any case, the population of Florida has more than tripled since this time, as you can see right here. So the amount of people in this thing's way is unprecedented, that we've never seen before. And thirdly, I want to quickly get into the elevation here. Look at this map right here. This shows the elevation of South Florida, and you can see that you really have to go all the way up, almost a third of the way into the state, before you start getting into this green color, which indicates where the elevation gets to 50 feet. In fact, it looks even more dramatic when you take a look at this map. And if you look at this figure here over on the right, everything in this this lightest blue shading here is under 10 meters. So you got to do the conversion. That's about 33 feet. And then everything under this second level of blue here that's not the ocean is under 5 meters. That's under about 17 feet. So, but in other words, the point is that look how far north into the state, up around Lake Okeechobee, or maybe just north of Lake Okeechobee, the storm has to get before it starts encountering any spot above 33 feet or any spot up here above 50 feet. And the reason why that's so important is because the hurricane is not going to weaken very much. One of the biggest reasons why hurricanes weaken when they start coming onto land is because they start running into elevation and their circulation is disrupted. Down here you have lakes and swamps and everything else that is just going to, it's not going to weaken it very much. So it's going to pick up everything, whether it's, you know, lawn furniture or a shingle off the roof or a piece of a palm tree, and it's just going to blow it, and it's going to keep penetrating inland, and then those projectiles are going to hit other structures, and then they're going to break off more pieces, and they're just going to keep compounding the winds as far north as this hurricane penetrates. So Orlando and Jacksonville and Tampa and all of Daytona, all these places are going to also receive heavy, heavy impacts. Finally, I want to show you this. This is the European wind model map, and it's in knots, so that means hurricane force winds basically start at this color right about here. But you can see basically everybody from this dark red to the brown color is going to experience hurricane force winds, with major catastrophic winds occurring in the southern part of the state. All of it's low. Notice it's wider than the entire state of Florida itself. This hurricane force wind field. So you could have everybody in the state of Florida east of this point experiencing hurricane force winds, with hurricane force winds possibly getting to Atlanta on Monday or on Monday. So this is going to be unlike anything we have ever seen. It could be over $500 billion. That's an estimate, but just based on everything I've looked at. But it's going to be absolutely awful and something that we just have not seen. And hopefully looking at this will give you a little better idea of what I'm seeing here as far as damage potential. But this is catastrophic. If you have people that you know in South Florida, please tell them to get out. Tomorrow, Friday, is probably the last day you're going to be able to do it before conditions start deteriorating there. So you need to start acting now. This is a very urgent situation. This could be one of, if not the, it will be the worst hurricane in history in terms of damage potential. Hopefully not in terms of loss of life. I'm Matt Gross with Lebanon County Weather, and good luck to everybody who is going to be down in Florida. in the middle of this.